Hey everyone, my name is Hunter McDaniel. I'm the founder and CEO of UbiQD. We're an advanced materials company powering product innovations in agriculture, clean energy, and security. And today I'm going to be telling you about the agriculture focus area. I'm super excited to be giving you this talk today for the Tech Blick online conference series. And I'm going to be focusing on our spectrum control greenhouse technology, and in particular, how we're using quantum dots to help feed the future. But first, I'd like to take a moment to acknowledge our rockstar team. You can see a photo here pre-COVID of us having fun up in the mountains just outside of Los Alamos, where our company is based in New Mexico. And we've really got a rockstar team here. Like I said, 24 full-time employees, a handful of MBAs and PhDs. We've raised about $10 million in outside capital. And combined, our team has more than $500 million of exit experience, something that our investors like to see. And you can see these logos here are from our various backgrounds, a number of leading research institutions and companies there. They have all the relevant industry experience we think that we need to take us to the next level. And in particular, our core management team is shown here. As I mentioned, myself as the founder and CEO, I was previously at Los Alamos, New Mexico, Los Alamos National Laboratory, where I was completing a postdoc with Viktor Klimov, one of the pioneers in the quantum dot research community. Matt Berggren is our chief of product. He was previously at the National Renewable Energy Laboratory. Lizeth Garay, VP of Operations, was previously at New Mexico Consortium. Mike Burrows, VP of Business Development, was previously at DuPont. Karthik Ramasamy and I worked together at Los Alamos National Laboratory. And then last but not least, Eric Moody is our Director of Sales, and he recently joined us from PL Light Systems, one of the leading horticultural lighting companies. So I mentioned that our company is an advanced materials company, and we truly believe that advanced materials underpin every major technology revolution in the history of mankind. And nanomaterials are going to be an excellent example of that. In particular, we focus on quantum dots. And if you're not familiar with what quantum dots are, I'd be surprised since you've been listening through this session on quantum dots. But in particular, our quantum dots are safer, cheaper, more stable versions of quantum dots, which are notorious for being tiny bits of material that enable efficient manipulation of color and light through a process called fluorescence. In other words, they glow. And in the past, in order to make a different color of fluorescent material, you'd have to come up with a new compound, a new dye molecule, a new phosphor composition. But what quantum dots enable is a tunable color through essentially the full rainbow spectrum of colors by just slightly tweaking the manufacturing process to make bigger or smaller particles. And that's what the quantum dot technology is notorious for, is the tunability of color. Just more specifically, for those of you that are a little bit more skilled in the art of quantum dots, our focus is on copper indium disulfide and related 1,3,6 compounds. These are enabling extremely high fluorescence quantum yield of essentially near unity as prepared, very stable, and we can tune the emission across the full visible into the near infrared. If you'd like to purchase our quantum dots, you can do so at Strim. We're in the catalog there. No questions asked. You can buy some materials there to do some experiments with if you've got some ideas about how you might use these. This is all enabled by a very efficient manufacturing process that I helped develop at Los Alamos National Laboratory. Just showing as an example here a 12-liter reactor, which would produce enough material for about 5,000 square feet of product in our first market, controlled environment agriculture, and more specifically in greenhouses, which is actually a massive global opportunity. There's about 54 billion square feet of greenhouses on the planet. Depending on how you size it up, this is about 20 times larger than the display industry opportunity for quantum dots. And in a greenhouse, if you've ever been in one, it's incredible. The conditions for growing crops is fully optimized, or nearly so, in that you have very homogeneous, identical plants that are producing upwards of 20 times more yield than you would get outdoors, with about 90% improved water use efficiency. You can keep the pests out with the structure, so you don't have to use pesticides. And this industry is growing rapidly right now, largely driven by climate change and